Hello everybody, welcome back to my channel. In today's project, I am going to be working on a sentiment analysis where the goal is to analyze our text data and determine whether the sentiment expressed is positive or negative. So we'll be performing binary classification. Okay. So let's begin with importing some necessary libraries like pandas to handle and manipulate data, and then NLTK. It is a natural language toolkit with tools for text processing, then stop words to remove some common words, and Porter stemmer and wordnet limitizer. It is going to help us to reduce words to their base form. Okay. Then import RE, that is regular expression. And this is going to clean up the text data. And then we are importing Veda sentiment to analyze our sentiments. Train test split to split the data. TF-IDF vectorizer to convert our textual data into numerical form or vectors. Then logistic regression and SVM, that is support vector machine. These are machine learning algorithms for classifying our data, classifying our sentiments. Then some matrices to evaluate our model's performance. We'll also be importing SMOP. This is going to help us to balance our data set. And then joblib to save our model so that we can use it later without having to train our model again and again. And warnings to avoid any unnecessary warnings. So first, we'll be importing our data. Import and load the data. We can see we have almost 13,871 rows and 21 columns, like ID, candidate, candidate confidence, relevant, confidence, and all of that. But we do not need all of this. I'm just going to need the tweets and the sentiments. Okay. So I will look here. All of this is not important. The tweet ID, location, the time zone. And I just want the text and the sentiment predicted. We have the sentiments here and text. So what I'm going to do is I'll be going to remove the unnecessary columns and keep only the text and sentiment columns and save it into our data frame. So here you can see this is the text column and sentiment, only two columns and all the entries. We have, as you can see here in sentiment, we have neutral, positive, and negative, three different classes of sentiments, and I will be performing binary classification. So therefore, I am going to drop all the neutral entries. Okay. So this code is going to drop all the neutral entries and save it into our data frame. Now you can see here we have 13,871 and now we have 10,729, which means all the neutral entries have been dropped. Now we have only positive and negative sentiments. Okay. Then I'll be going to loop through each text in this data set and print it. Okay. Each text here. So you can see it here. All the texts have been printed. Okay. Everything. We can just, this helps us to get a look at our textual data. Okay. So we have retweets, at the rate symbols, hashtags, and links, which we do not need. We just need plain text. So I'm going to define a pattern, create an instance. This is a regular, sorry, define a regular expression so that it can match certain elements within our text, like retweet to match with retweet. Then we have the links to match, then hashtags. Slash W plus means more than one word. Okay. Slash S means to even remove the space that we do not need. So what this first expression tells us is a word that starts with R and T has a space and is followed with at the rate, and there are words followed. That's why we are saying W and then plus everything after that. So we have defined this regular expression and stored it into a pattern. Then I'm going to create an instance of Porter stemmer and wordnet limitizer. Stemming is going to, help us to reduce words to their base form. Like running is going to become run. It is going to convert it into the base form. And limitization is going to reduce the words to their dictionary form. Stemming will reduce words to their base form. Sometimes they will have meaning and sometimes they won't. So we are going to use lemmatization so that the words have some meaning, dictionary meaning. Next, I'm going to download some necessary resources from the analytic library to help with lemmatization and to remove common words and split the text into sentences or words. Okay. Now going here. I have defined a function clean data. Can pass my data frame. I'm creating two empty lists, text and sentiments that will store the clean data, clean text and their respective sentiments. Here, the next I'm going to look through uh, you know, each text in the data frame and remove unwanted elements from the text by matching it with the regular expressions that I have defined earlier over here. So this is going to loop through each text and match it with this and then remove those. Next, I'm going to split the sentence into words and then convert each word into lowercase. Once they're converted into lowercase, we'll be removing some common words and reduce each word to its base form. And then store the cleaned words into the words list and then join the cleaned words back into a sentence and add it to the text list. Okay, this and then add sentiment from the original data to the sentiment list and return the cleaned and pre-processed text data and the corresponding sentiment labels. Okay, so let's just okay here. This line is going to process the original text data, cleaning and dealing it to the text and sentiment columns with the data frame. This is just going to take this clean data and replace the clean data in the data frame with the text and sentiment column names. Okay, have a look here. First, we had all these retweets and hashtags and at the rate symbols, everything. Now have a look here. It is clean. There are no at the rate symbols or anything, and the respective sentiments have been stored. That's what we did over here. Okay, now I'm sorry. Okay, here I'm going to use a sentiment intensity analyzer from Veda to analyze sentiment of each piece of the text and use a polarity score that is going to return the dictionary with sentiment scores for each of the text. It is going to tell us the level of positivity and negativity in the text. Okay. Next, I'll be using label encoder that is to encode my sentiment column like positive and negative uh, into numbers. Like positive will be given 1 and negative will be given 0. So let's move ahead. Now I'm going to use a TF-IDF vectorizer that is going to convert my textual data into numerical form or vectors we can say. It is going to consider single words or word pairs and triplets as features and then calculate the importance of each feature based on how often it appears in each text and how rare it is across all texts. Okay, that is what I have defined here. You can see it has converted my textual data into vectors. Have a look here. Everything is turned into numbers. Okay, now we have to, train our data and test it. So model building, we have entered into model building. So I'm going to use the train test split to split my data into training and testing set. And I will be using a testing size of 20%. Okay. Uh, First I'll be, training my model using logistic regression. So I'm going to initialize logistic regression and then assign different class weights to handle imbalance, like 1 to negative and 1.5 to positive, and then train my logistic regression model using training data, and then use this trained model to make predictions on my data for both for training and testing data. We can see our model accurately, predicts 85% of my test data. And a classification report shows that the model performs well for negative sentiment, but it's struggling to identify positive sentiments. You can see for negative, it is 87% as precision, recall is 96, F1 is 91. So it's performed amazing for negative sentiment. But for a positive sentiment, precision 74, not bad. But recall is 44 and F1 score is 51. So it is struggling in a positive sentiment. Okay. We can even check a cross validation, CV score. So I'm going to perform a five-fold cross-validation in my training data to see how well a model will perform on unseen data. Okay, so I'm getting a 84% average, 84 to 85% average. So it says, let's say our model is performing consistently well. Okay, even though a logistic regression is performing well, I'm going to still go ahead with support vector SVM because it is better at separating different classes of data. Okay, and for SVM, I'm going to use an RBF kernel to handle the nonlinear relationships in data. Have a look here. SVM is also giving us an accuracy of 85%, and a classification report shows that it is even for SVM. Model is performing well for negative classes but is struggling in positive classes. Cross validation score says 85%, which means it is performing very similar to a logistic regression. Okay, even though both our models are giving us good accuracy, they are struggling in correctly identifying positive classes. So I'm going to use a technique called SMOT. Okay, this technique is used to handle the class imbalance by generating synthetic samples for the positive class or minority class, we can say. In our case, it is the positive sentiment. Okay, so I'm going to initialize more and set a sampling strategy of 75% and then resample my training data with more balanced classes and then going to use this resampled data to train my logistic regression and SVM model. We can see logistic regression by using our resample data. The accuracy has decreased, but it is performing well for both positive and negative classes. See, this percentage has increased. Whereas for SVM, the accuracy is consistent. It is same 85%. The performance of recall and F1 has not, does not improve, but at least accuracy is same. Whereas in logistic regression, accuracy has decreased. So I'm going to use my SVM model because SVM with SMOT and without SMOT has given me some pretty much same results. So it is performing consistent. So I'm going to use this SVM and go ahead to make prediction on my unseen data. So I'm passing this sentence statement that amazing experience from start to finish. Highly recommend to everyone. This is basically a positive sentiment. Let's pass it to my model and see what it predicts. Okay, I've passed this for loop that says if our model has been encoded for sentiments. So 0 is for positive and 1 is for negative. That's why I'm using this for loop that returns positive if it is 0 or else it's going to return negative. A statement has been passed and a prediction was positive, which means my model has predicted it correctly. So now I'm going to save this model and my TF-IDF vectorizer, okay, because I'm going to deploy it using a web page. Let's go to my Spider environment. Here I've written a code to import my both the modules that I have saved, the model and my vectorizer. I'm going to write a streamlit code that is going to take text from user. I've defined this function where whenever user enters a text, the text will be vectorized using my TF-IDF vectorizer and use the model to make predictions and then return the sentiment. Okay, so I've done that. Let's see here. Okay, let's pass a sentiment. I already have one. Let's pass something else. I've already tried this one. Let's just say the product was not good and the experience was terrible. It says negative. It was a negative sentiment and it has predicted it as negative. So our sentiment analysis model is working perfectly fine. It is making some correct predictions to 85%. So I think it's a nice one. I have deployed it not deployed it, I just created a small web page using Spider and Streamlit. So thank you guys and please follow for more content.